Okay, good morning. So we were supposed to do some physics today, but it's mainly mathematics, so just the rule we will use from physics. Okay, so I will start with a problem, because I don't know your background in physics, how it works, but let us see what can we do. So let me start with a problem, okay? So you have, for example, you have an uphill here. Let me just model it with a right angle triangle. So that is the ground level, and then you have a little bit of uphill, and then you shoot a ball or something with some. So this angle, let me first of all give you this angle. This is the inclination angle of this inclined plane, yes, surface, and then I shoot a ball or whatever with given speed v naught, but of course I should say given velocity because I want to show it with a vector. So its magnitude is v naught and its direction makes an angle beta different, might be not exactly the same. So in my picture it's probably this is the same, but no, alpha is fixed, beta I fix it, and I shoot my ball or my particle, and it takes a trajectory and actually hits this inclined plane at some point. Yes? I want to calculate this length. Okay? So I want to see how long, how far it goes on this uphill. So let me call it D. I mean, if I call this one O, if I call this one A, I want to calculate this. So what I provided for you is, of course, there are some instruments that you can really measure this incline. So I think it's very, very simple one these days. And of course, you can fix in a way that you really shoot it with angle beta regarding to this inclined plane. And then you can probably know about the speed that you can shoot. So these are the things I give you, alpha, beta, v naught are all given. And I want to see that if I ignore the air drag, of course, where this will end up on this inclined plane. So my goal is to calculate this distance d. And then when I say that calculate this distance d, it means that give me a formula so that expresses d in terms of the given parameters of the problem, including alpha, beta, and v naught. Yes? That is the point. Okay, as I told you, because I don't know your physics background, let us just start thinking about the problem together. So how do you think about the problem? So if you want to start solving this problem, what do you do? Now, I mean, what is the general setup if you want to solve this mechanical problem? Yes. So where do you start? Yes?
Splitting up the vector in x and y on the x and y axis.
No, before that, completely from scratch. Because you know that this is not mathematics, this is a law of nature, yes? But that law of nature is expressed in a mathematical form. What is that law of nature? It's a very, very elegant and simple formula discovered by, yes? So let me tell you something. In mathematics, we have some axioms, yes? So it means that we accept them to be true, and then we start deducing true statements from that one. The axioms in physics, axioms, so in mathematics, axioms are just axioms. For example, consider the chess game. So one axiom is that the bishop moves, I don't know, in a crossway. That is not, we can say why, yes? That's just the rule we accept and we enjoy the game. So mathematical structure is very similar to the chess game or whatever game it is. So you have a set of rules, you accept them, and then you make a structure on top of that. That's a mathematical structure. The first principles, you don't need to prove anything. You accept them. And then, of course, you want to keep the number of them as low as possible. It's always, yeah, that's no problem. Yeah. Yes, and then in mathematics, we essentially can have any statement. But in physics, we cannot say any statement. We can have axioms again and say that if the nature works like that, these are the consequences. But there is a big if really the nature works like that or not, it comes from experiments. So that's the only point. So you do some experiments, you get motivated, okay, this seems to be the rule governing this phenomena. Yes, and then you state it as an axiom. You say that, okay, if the world works like that, this is my axiom, then I will actually calculate things. And then what happens is that if you go in the future, might be you get some deviations from the predictions of that law. And it means what it means, then you do two things. First, you start recalculating things. Might be you have done some errors in your calculations that you see the deviation. Or if you are now completely sure that you haven't done any mistakes in your calculations, then it means that the law itself should be modified in a way that it should actually contain these consequences that you are looking at. So this is the way that physics works. Okay, but now here you have this phenomenon, and then you want to understand it. So there's one law governing this. If the person who invented that or discovered that is true. What was that law? What's the law? All mechanical problems are starting from which law? Actually, three laws.
Okay, so Newton's laws.
Newton's laws, yes. So the second one is actually very important. So the second law, so the first law actually tells you that there exists an inertial reference frame. What does it mean? It means that there is a frame of reference in which if the total force is zero, the acceleration is zero. Okay, so that's an axiom because we cannot prove that such an inertial frame actually exists. We accept that there is one, and then we work on in it. And in it's Newton's second law. Here we don't need the third law. Here, but what is the Newton's second law? So it's a very, very simple and elegant formula, yes?
F equals m.
F equals to ma, but now I don't know how you have studied that, but we know that F is a vector. So let me just denote it with a vector. M, the mass of my particle is just a scalar, but acceleration is also a vector. Force is a vector because it not only contains magnitude, but also direction. The same is true for acceleration, yes? And then, so this is the total force. If you want, I can write this here. So this is the vector sum of all forces acting on my particle, yes? And then this is the acceleration. And of course, what is the acceleration? If I have, so acceleration is the derivative of velocity over time. This means the derivative with respect to time. So that's the Leibniz notation. Usually in physics, people use the Leibniz notation more. Okay, and then of course, velocity itself is the derivative of position with respect to time. So this is dr. R is the vector pointing, so that locates the position of my particle, yes, and then dt, and then I have another d dt here, okay. So this d dt is the one that I have written here. It means the derivative with respect to time, and v itself is the derivative of position with respect to time. So then it means that this becomes the second derivative of position with respect to time. And this fancy way is just the second derivative. You can write it like that. Yes? But in physics, usually they use it. And then in physics, it's also very common. Instead of putting primes, they put dots. So they say r double dot. So this means dot is derivative with respect to time. if it is with respect to other variable, because time is very important parameter in physics, so they have invented. So if you want to say, you can say that the velocity is r dot, the first derivative of position, and then you can say that acceleration is v dot, which is equal to r dot dot. Yeah, these are the notations used in physics books, but it's just derivative, yes? Okay, so we have to start from here, because that is the only law governing this phenomenon. Yes, so what I have to do, I have to understand the total force acting on my particle. I have excluded the air drag, so I don't need to be worried about any friction force. So there's only one force acting in this game, and what that is. So if you shoot the particle, of course in the beginning you shoot it, but when it is in the way, you don't have any effect on it. So there's only one force acting on this, and that's the force of gravity, yes? And the force of gravity close to the Earth can be approximated with this one, yes? So the total force here is what? The force of gravity, which is the mass, yes? But multiplied by vector g, yes? G is the acceleration due to gravity, but because that's an acceleration, it has to be a vector again. Yes, usually G is the magnitude, without this symbol, is the magnitude of that vector, if you want to. And this is an experimental fact that it would be around 9.8 meters per second squared. Yes, but we don't need to be worried about that. We just take it as G. So whenever I use G, I mean the magnitude of the vector of the acceleration due to gravity. So it's always positive in my notation. So G is just a positive number which represents the magnitude of that force. Okay, so the total force in this case is this, and that is it. So I put them equal to each other, yes? So this means that MA is equal to mg. And then I cancel this m. By the way, what type of product is this? It's like a number multiplied by a vector. So it would be a vector parallel to A. Yes? So I can cancel m from both sides, and then A becomes G. Yes? Okay. But now I am working in only 2 dimensions, so I can safely work with 2 coordinates, not the third one. Yes? So let us just ignore the third dimension for examples. But can you just tell me now, if I want to start this, what I have to do, I have to, usually, you see there are no coordinate systems. In physics, when I am doing some experiments, there are not coordinate systems in nature. But if I want to work and solve something mathematically, I myself set up a coordinate system. And that coordinate system is completely arbitrary. Yes, you really don't need to care about that. But of course, if you are careless, you will set up the coordinate system in a way that the mathematical equations become complicated. So this is important to choose the best possible, that comes by experience by the best choice for the coordinate system. What is probably the natural coordinate system that you have seen in projectile motions is probably taking the horizontal to be the ground level and the other one vertical to that. So I will set up a coordinate system. Whenever I start, you see that is the formula in physics, but if I want to do some mathematics, I have to set up a coordinate system, and the coordinate system is completely arbitrary. Of course, different coordinate systems will give rise to complexity, more complex mathematical equations. So let us take this one and work here. If I do that, it means that, what can I write for A? A is the set, so what can I write for R? So let me call this one the position of my particle here. I can denote it by this vector R. Yes? So this position has an x, so what is the components of this vector? Let me call this one x, let me call this one y. If someone asks you what are x and y, I would say that x and y are components of this vector, and this vector is called the position vector. It denotes the position of my particle. So if I say that what is r, you remember in analytic form, a vector is here two components because I'm working in two dimensions. The projection of the vector on the x-axis, I called it myself x, and the projection of this vector onto the y-axis, I myself called it y. Yes? Is that right? Okay, and it turns out that if I want to find a derivative, I need to calculate the second derivative. Let us do it a little bit as you are familiar with. So I just take the second derivative of r, but it turns out we haven't talked about this in our course, but if you want to take the derivative of a vector, you can do it component-wise. Yes? So this is the only thing that I am actually selling you without proof. So I take the derivative of x, and I take the derivative of y. Yes? Okay, now this is the vector A. Okay, but can you tell me how can I write vector G? Where is G? If I want to show somehow vector G, what is the direction of vector G?
Straight down.
Straight down, yes? So this would be, for example, here, straight down, and this is vector G. But be careful, this vector G is position independent. Even if the particle is here, the acceleration is exactly the same, even if the particle here. So if you are around the Earth, this acceleration is always pointing downward, yes? So that is why you remember when we were talking about vectors, we said that the vectors doesn't have any locations. So the vector is just a vector independent of the location of that vector. But now can you tell me what are the components? You need to tell me what is the x component. Do you remember what was the notion of the component? You need to project it onto the x and y axis and then look at the shadows, yes? And then that size, that length, considering the direction, is the components of your vector. So what is the length if I project this vector onto the x-axis? What is that length?
0.
0. Yeah, so the x component of my vector is 0. Yes. What is the y component? I have to project it onto the y. So what is that? Here we have it. Yes. So because the length of this vector is a number, yes, but I told you that for that number I use letter G. And I told you that by my convention I will take it positive. So what can I write there? 0 and?
9.8.
Forget about 9.8. I want to put G, but not G. Because I have put the coordinate system pointing upwards.
Oh, so
On the minus.
So that should be minus G. I could have chosen the y direction in that case, then I had to write positive G. Yes? So here I have to write negative G. So don't get confused. This is my vector. This is a number. Yes? So that is it. And then I equate these two vectors coming from the Newton's second law. Yes? So what happens is this. I have x double dot, y double dot, sorry, so x double prime, y double prime is equal to 0 and minus G. Yes? As simple as, so you see that I started from Newton's second law. I want you to see the connection. If Newton's second law was not there, we couldn't write this. And then we learned that this is a vector is supposed to be equal to another vector. Vectors are equal if and only if the components are equal correspondingly. So what happens, it means that I get a system that x double dot is 0 and then y double dot is negative G. Yes? But remember, what is x and y? I want you to don't get confused. In mathematics, I write y equals to f of x. It means y is a function of x. This is the standard symbols that we use, the relations. But here, can I say x and y are functions? And if yes, function of what?
they're a function of the path. The vector I take.
No, not in this form.
Okay.
Not function of the path.
Oh.
Yes?
Is the function of the acceleration.
No? No simpler than that. They are function of? So let us say it in this way. What is the initial x and y coordinates when my particle starts moving? What is the x and what is y?
0.
0 and 0. And by passage of time, x and y are changing. So what does it mean? It means x is a function of time, y is also a function of time. Yes, is that understandable? Yes. So x is a function of time, y is also a function of time. Yes. And one thing that you can see here is that these two equations, which we call differential equations, we will study that in Math 5, they are not connected. You see, x has nothing to do with y, and y has nothing to do with x. So it means that what happens on the y-axis is independent of what is happening on the x-axis. So you can view them as two different motions. One motion along the y-axis, one motion along the x-axis. But forget about that. Let us do mathematics now. Yes? So what is x? X is a function of time. If I want, I can write it like that if you want to. X is a function of time whose second derivative is 0. So what is its first derivative? Can you tell me?
A constant.
So a constant. So let me write x prime of t is a constant. So let me call it c. Yes? Now I ask you, what is the function xt itself at the end? You need a function whose derivative is a constant. So what that function is?
X.
Not x.
T.
Variable is t. So it becomes ct, but this is not finished.
Plus a constant.
Plus a constant, which I call it d. Because we don't know. Might be that constant is not 0. When you write ct, it means that you're assuming the second constant is 0. We don't have any reason for that. So you see, this is the form of x. So it means that if I shoot the particle here, what I see is that x as a function of time changes linearly. C times time plus d. But of course I don't know c, I don't know d. Yes? But we can find them. What are c and d in this case? Mathematics cannot fix that unless you give me some initial conditions. Yes? X is ct plus t. I want to find c and d in this problem. So that is completely generic. If you see, even if I have shooted this particle not from here, the physics equations remain the same. None of them are sensitive to my initial conditions. Yes? So by changing my initial condition, if I shoot it stronger or weaker, I will get the same equation. So you see, the equations in physics are so far are not sensible to my initial conditions. Now the sensitivity is coming from c and d. So how can I fix c? How can I fix d for this problem? Yes.
For t, you put t equals to 0.
Yes, because you see that I know something. In this coordinate setup, yes, x at 0 is what? X at 0 is 0. So it means that when I replace t with 0, the answer should be 0. So this gives me that d is indeed 0, as you just coincidentally predicted. So d is 0. But what about c? What about c? C is, you see, c is the derivative of x with respect to time. What is the derivative of x with respect to time? Is actually the velocity on the x-axis with respect to time. Yes? Is that understandable? And that is supposed to be equal to c. And by the way, this is very interesting. It means that the speed, the velocity on the x-axis is a constant, independent of at which time I am looking at it. So it means that it goes constant. If I look at the shadow of my particle, I don't see the particle above my head. I just see this shadow. Shadow is actually moving with a constant uniform speed. Yes? So that is the prediction of the formula, and actually this is the case. So this becomes c, and I want to find c. So this means that the velocity at initial time x is equal to c. Yes? Because at any instant of time, velocity along the x direction is c, including the initial time. Is that understandable? But we know what is this. Can you tell me what is this value by the condition in the problem?
Initial velocity or VC?
No.
Or, oh,
VC is the is
oh,
the
V0
vector.
times cosine.
Yeah, exactly. So you need to find the component. So if I ask you what is V node, you say that I want to write the component of this vector along the x direction, so which becomes what? V node. This V node, if you want, I can put the norm of vector times cosine of which angle?
Beta plus alpha.
Beta plus alpha, yes, alpha plus beta. And then, what is the y? One is V node. The norm of this vector is sine of alpha plus beta, yes? And then if you don't mind, from now on, let me just write only V node for the speed, okay? Speed is the magnitude of the velocity. Let me show it simply for V dot, yes? So this becomes my V node. Okay, and then what is the Vx0 according to what I have is this one, is V node cosine alpha plus beta. Yes, this is on the one hand from my initial condition. On the other hand, this is supposed to be C. Yes, so it means C is this number. Yes, so this means that C is equal to V node cosine alpha plus beta. Okay, so what is the, understand, so what we can get, so let me write it here. What I get is x of t is this number times, is this number times t. Yes, because I didn't write it here, sorry. X of t is ct. And then I got c, I put it there, so this becomes V node cosine alpha plus beta times t. Yes. Of course, you knew this from the beginning, but I started doing everything from scratch. That is nothing. So in the physics courses, probably you have learned that the motion along the x direction is a uniform motion. The only thing that you need to do is to find the velocity along the x direction, and probably you know that you have to multiply this by the cosine of the angle that this is making with the horizontal. That would be the velocity along the x direction, and because that's a uniform motion, you just need to multiply it by t. But I want to see that we proved this by one axiom, and that axiom was the Newton's second law. So if you admit that Newton's second law is the law of nature, these are the consequences we are exploring. Yes? Okay, so that is x of t. But the problem here is more or less the same thing. A little bit more complicated, and you will see why. So what can we do here? Let me just clean this one, because we have already done x of t, so I don't need it. Yeah, let me clean this. And just now concentrate on the second equation here. So what is y prime? Y is a function of time again. Its second derivative is minus g, so it means that its first derivative is what? What is the first derivative?
Minus dx plus constant.
Not x. Minus g
t
plus a constant. I have used c and d. Let me use e this time. Yes? And then if I ask you what is y itself, what is y itself? Is a primitive function for this. A primitive function for, this is a constant. Yes? But what is a primitive function for t when t is my variable?
T squared divided by 2.
Divided by 2. So I put 1 over 2 here and t squared here, and I think this is familiar for you, yes? And then when I go here, what is a primitive function for the constant e?
T.
et, yes, and then might be another constant, so let me call it f. And that is also famous formula, yes? So it's a consequence of Newton's formula. Again, this is completely generic. I need to fine-tune E and F so that this matches with my problem. But finding F is again easy. Can you see what is F? Because we know where the particle starts. It starts when y is 0. Initially y should be 0. It means that if I replace t with 0, the value for y should also be 0. So this means that f is 0. So if you don't mind, let me just ignore f. So f is 0. But what is E? Can you tell me what is E now? So you need to go here. What is the physical interpretation of that? This is the velocity along the y direction is equal to minus gt plus E. So this means that the initial velocity along the y direction, I replace t with 0, it becomes E. So the physical interpretation of this constant is the initial velocity of my particle along the y-axis. But I already know that. I have it here on the board. So it is v naught sine of alpha plus beta. So this means that E is that number. So E is equal to v naught sine alpha plus beta. And then what I do, I put it back in that equation and I find my y of t. So this becomes minus 1 over 2 gt squared, and then plus E, which is this number, times t. Of course, I don't know, have you already seen the proof? You really don't need anything here, because what you have learned in physics, you could in principle write these two equations immediately. Yes? But I don't know, have you already seen what is the proof for that? I want you to make sure that you see the proof. So that's coming exactly from Newton's second law. It's nothing except just Newton's second law. Okay. So you see x is a function of time, y is a function of time. But sometimes, if I ask you which one of them is representing this trajectory, what is your answer? Is one of them, or both of them, or or any kind of relation between them, gives you the equation for this trajectory? Because you see, all of us know that this should be some curved trajectory. But there are a lot of curves. That curve could be, I don't know, a part of a circle, a part of an ellipse, a part of a very complicated trajectory. So how should I know that? What is the nature of that curve?
I mean, you need both of them to make that curve.
So what does it mean? So if I want to find an equation for the curve in the xy coordinate, I want to find the relation between x and y. If I can find the relation between x and y, then I will be able to look at the formula and hopefully I can recognize it with a pattern that I already studied in mathematics. Yes? I don't know. Do you know what is that? Do you think the trajectory is part of a circle? Or part of an ellipse? Or part of what? Do you know that?
Yeah.
Yes?
It's a parabola.
It's a parabola. Yes? Why is that? Because if you start finding the connection between x and t, you see that a second degree equation appears for x and y. So that means that this trajectory is indeed a parabola. By the way, might be we don't need it right now, but let me calculate that. Okay? So let us see in principle. Tell me, how should I do that? Now it's completely mathematics. Physics is finished now. We have to do a lot of mathematics now. So I want to find a relation between x and y. Connect. So x, by the way, this is called parametric equation. Parametric equations of x and y. X is connected to t. Y is also connected to t. In principle, x and y are also connected. Yes? And that I want to find the connection between x and y directly, not indirectly. So how should I do that? The strategy at this level should be a matter of seconds. I want to get rid of what variable? I want to find the connection. X is connected to t in my equation. Don't let these things distract you, because V naught, alpha, beta are all constants. So at the end of the day, this is just a number, 5t, whatever. Okay? And this is also a number, that's also a number, so t. I want to get rid of which variable to see the connection between x and t directly. X is connected to t, y is connected to t. I want to see the connection directly. I should get rid of which variable?
T.
T. And then if you, so that is why I want this. It shouldn't take 2 seconds. You need to know what to do. Yes? So you want to get rid of t. So what you are supposed to do? For example, you should calculate t from one of these equations and put it in the other one. It might be complicated. Who cares? This becomes an equation independent of t, and that's my goal. But of course, you need to be a little bit smart. If you want to choose this, you'll make your life harder for yourself. Because if I want to find t, I have to solve quadratic equation because that's a square. I have to use ABC formula. Yes? But I myself prefer to use this one. So that is, you see, these things you have to learn. And so this t becomes, and if you don't mind, let me suppress t. Every time that I use x and y, I mean x of t, y of t. So t becomes x divided by v naught cosine alpha plus beta. Yes? And then I plug it into the equation here. So y becomes equal to minus a half g. Instead of t, I have to put this squared. So this becomes x squared. The denominator is v naught squared cosine squared alpha plus beta. And then I have v naught sine alpha plus beta. And instead of t, again I put this expression. This becomes x v naught cosine alpha plus beta. Yes? And then what happens if I do simplifications a little bit? So I would write it as minus g. I multiply these two here and write it in the denominator. And then what is left for me is x squared in front. But this v naught and this v naught are cancelled, and we have a better name. Instead of writing sine over cosine, I just simply write what? Tangent. And then I have 1x here. So that is the equation of the trajectory. But look, this you need to learn. So this g minus 2 v naught cosine alpha is just a number. Yes? They are given to you in the problem from the beginning. So you can assume that that is a constant. And that is also the same thing. That is also another constant probably. And now look what happens. You have y equals to ax squared plus bx. And I hope that everyone agrees that's a parabola. Yes? So that's an equation of the parabola. Okay, in the physical ground, do you expect that this parabola has a maximum or a minimum? You can see it on the picture. Is it opening upward or downward? So what's happening here? Yes? So we have something like that. Yes? So the parabola should open up. Is it seen from the formula that this is indeed the case? But so you see, in physics, you don't expect you shoot the particle and particle goes in this way, yes? The particle goes in that way. But when it comes to mathematics, you have to prove it. And that is very good to see the interpretations between mathematical equations and physics. So from physical point of view, because we have grown up on Earth, so we know that this will happen. But how mathematics is saying me that?
Because the first one is negative.
Negative, yes. G, I told you that's positive. V naught is the magnitude of the velocity, positive. alpha plus beta, whatever, cosine squared is positive. So that one is positive, but I have a negative sign. So definitely this is negative. So if this coefficient is negative, you know that the parabola should be this, and that is intuitively also correct. Yes. Okay. So that is the trajectory. So that is the equation of the trajectory, and we'll learn that is actually a parabola. Okay. Now, I want to stop because that was not my goal, even though we need it. But my goal is to find D. What is your proposal? From here to here. Let me make sure that you know. Assume that this was not there and it will go back and hit the ground. What is the range? How do you calculate the range? The range is from here to the point that this particle hits the ground again. How do you calculate that? Can you tell me? Yes?
You find the intersection on the x-axis.
On the x-axis with the
With
this equation, or that equation. That equation, because that's the trajectory. So it means that you need to equate it to 0 and find x. One x is clear. It's the origin. Yes? And that's clear because if I put it equal to 0, then I factor x out, and then one solution is 0. So that was predictable. That's not very important for us. The next one is important. The point is that, so you know that, that's good. But now the point is that I don't want to, I will not be able to reach the ground level because I will hit this inclined line. So the point is that, I don't know if you can call it range or not, but the range is usually around the horizontal. So this one, what can I do for this one? How can I calculate this? We don't need these, so let me just remove them. So do you have any idea now what to do to calculate D?
You find the intersection of the curve to the slope, the function of the slope.
Your idea is correct, but can you do it practically for me? So one thing is that, yes. So what Ruben is saying is that let us completely forget about physics. Now let us find this point. This point is clearly the intersection of this parabola that I know the equation with this straight line, which I don't know the equation yet, but I think it is a matter of seconds for you at this level to find an equation for that straight line. What is that?
Oh, tan alpha x. Or
Tan alpha x. Yes, is that right? So the equation is, because you know that this line is passing through the origin, so the K form should be like this. Yes, because the y-intercept is 0, so let me just remove that. And then I told you several times, another good interpretation of this slope is the tangent that the line makes with the positive x direction. And that angle is given to me alpha, so K is just tangent of alpha. So that's completely correct. So what I do, I set up a system of equations. One equation is a little bit complicated here. So minus, if you don't mind, let me stick to this convention. Let me call this one A, let me call this one B for the time being so that I don't need to write so much. This becomes ax squared plus bx, and the other one is y equals to tan alpha and times x. Yes? And then what I do, I need to find the intersection points. Of course, before starting the calculation, one intersection point is clear. That is the origin. And this will be given to you by the equations. So I equate the x value, the y values. Okay? By the way, of course, here I want you to tell you something. Can I divide by x? When I divide by x, I have to be sure that x is not 0. So when I divide, I'm implicitly assuming that x is not 0. Of course, x equals to 0 is a solution. So I would say that x is 0 is a solution, which was physically trivial for me. But now assume, I'm asking you, is there any non-zero solution? If that is the case, then I can divide by x, yes? I can do this only if I know x is equal to 0. I already know that x equals to 0 is a solution. Now I am asking myself, is there any other non-zero solutions? If the answer is yes, I am allowed to divide by x. Yes? And then I am looking for this x. So what I have to do, x becomes tangent of alpha minus b divided by a. So that is my x. And then what is y? Y is tangent alpha multiplied by the x I found. So this becomes tangent alpha multiplied by tangent alpha minus b divided by a. Yes? Okay. Okay, then what? So if I ask you what is the interpretation of this, it's a bad notation, sorry. This a is not that a, so let me remove it, okay? Yes, that was the point made. So here, that a that I am using is this quantity. So what can I do for finding the distance? There is a distance formula, yes? So you have the coordinates. These numbers that I got are the coordinates of the intersection point, and I want to find the distance to the origin, yes? So the distance to the origin is what? Square root of x squared plus y squared, yes? But because I don't want to carry this square root sign, if you don't mind, let me get rid of it for the time being by squaring it. And then I will actually simplify that later. Take the square root at the end. So what is x squared? Is this expression squared. So you see, everything now is mathematics, nothing related to physics. So physics is finished when I got the equations, yes? And then plus the other one squared. Yes? In principle, we are done. Yes, because do you agree that we are done or not? D is square root of this quantity. Do you agree with me? Because are A and B known to us or not? You see, A is this constant, G is given, we know this given, alpha and beta are given, so A is known. And then B is also known, yes? If I put them here, this number is known to me, this number is known to me, what I need to do is square them, add them, and take the square root sign at the end. Yes? But this is an A-level question in a university physics book. Okay, so they have provided you with the formula that you were supposed to get. So it means that you want, so you see it was for the, I don't know, university physics, they consider this a hard problem. I don't know how do you think about it. But they have provided you, might be the mathematics becomes a little bit complicated because I see this is the formula in the book. D is equal to 2v node squared cosine alpha plus beta times sine beta divided by, I hope that I haven't mistake taking notes, but this is supposed to, you're supposed to show this one. The reason that this is probably considered a level question in a university physics book is because this is not acceptable. Even though you have done everything right, but you have to simplify this expression and convince yourself that this expression is equal to that expression. And by the way, that expression is probably much more comfortable to work with, yes? Because immediately you see the connection between D, V node, alpha and beta in front of you. It's a little bit hard to see the connection here. Okay, so how should we do that? Now do mathematics for me. Can you do it? By the way, remember, this is D squared. Okay, don't clean these things. Let me write them somewhere because I will need them. A is this expression. b is this expression. And now I can clean it. Do you have any idea, if you want to simplify such an expression, what is your starting point? You have enough experience in mathematics, by the way. You should be able to do that. So that is more or less trigonometry. Trigonometry, identities or whatever. So how should I do that? I just wait for you to give me the starting. And of course, one way is to raise it to power 2, use the squaring. Yeah.
Yeah, one thing, we see the sine and cosine involved. So we,
Yes.
So we convert tangent to sine alpha divided by cosine alpha.
Isn't it too early?
Yeah, maybe it is, but that's the only thing.
Because you see, the tangent alpha appears alone. But the combination, of course, you're right, there is no alpha. So there's no, so yeah, we can do that. But then you also need to think, if I want to do that, then it becomes sine alpha, then it becomes minus b cosine alpha, and there will be a cosine alpha here as well. So it might be at this stage I make it more complicated. Not so there's, yeah.
I would replace A and B with the actual.
Not now, because what is the benefit of doing it right now? You will make it more complicated to write.
It's just because I want to bring the A, because that's also a division.
Yes?
So I want to bring it up and make it into one division and not a division of a division.
Yes, all of them are right, but there is something, I don't know, it might be, I don't know why I can see it, you cannot see it. Before replacing things, by the way, this might be, I already have trained myself like that. Before replacing anything, can this one be simplified a little bit more? If this is yes, I will do this simplification first, then I will bother to put these things in. But there is something in common between the first term and the second term, yes?
The denominator.
More than that. The denominators are the same, but tan alpha minus beta is also appearing here, so I can factor it out. Yes? So let me just tell you. So first of all, let me write this. Do you understand that or not? If not, I will explain. Is that understandable? Because tan alpha minus beta b to the power of 2 divided by a squared is exactly this expression. But this expression also appears here. And then there is a tan squared alpha. So when I factor it out, 1 is left from here, tan squared alpha is left from there. Yes? Is that right or not? But hopefully, might be the reason that I appreciate this, because I know that there is a formula for it. And hopefully you remember, what is that one? Is 1 over cosine squared alpha. So then, let me write everything here now. So cosine squared is 1 over, so it goes down. Yes or no? Okay. So it is easier now. Do you agree that working with this is easier than working with that? Yes. So now, by the way, this is d squared. I want d. So I can just read up all the powers of 2. So d becomes what? tan alpha, but absolute value. I don't want to put absolute value, but I should have a good reason why now. So let me write it so that you know. Because there are no exceptions, yes? I have to put absolute value. Yes? But do I need absolute value here?
No.
Actually,
No, wait, yeah.
A is negative, right?
now this is a very good question. Do I need absolute value here?
Oh.
I thought that this should be easy, but you need to be a little bit observant to see. Do I really need? So to see that if I really need this one, I need to make sure if this is positive or negative. What is A? A is positive or negative?
It's negative.
A is negative. Because everything here is positive except I have a negative sign. So A is negative. Oh, sorry. A is negative. What is cosine? Positive or negative? Cosine of alpha. It's a physics problem, so you're not shooting backward. So alpha should be somewhere, yes? It's not a negative slope that you're shooting. So alpha is somewhere in the first quadrant, so cosine alpha is positive. What about tan alpha and minus b? What is b? B is tan alpha plus beta. This one is tangent alpha. Tangent alpha minus tangent alpha plus beta. Positive or negative? The numerator. Because of course if I ask you what is tangent of alpha, you say it's positive, because alpha is in the first quadrant. If I ask you what is tangent of alpha plus beta, it's still positive, because alpha plus beta is still less than 90 degrees. If it is bigger than 90 degrees, you are shooting in that direction, yes? But tangent alpha minus tangent of alpha plus beta, positive or negative?
I would guess negative.
Negative, why?
Because, okay, so my presumption is that tangent of alpha plus beta is closer to 45 degrees.
No, closer to 90 degrees.
90 degrees.
Because you don't know is it closer to not 45 or not, because I don't know what are these numbers.
Yeah.
But definitely alpha plus beta is closer to 90 degrees. So this means that its tangent is larger. Yes? So this means the numerator is negative. Negative, negative, positive, it is positive. So I am relieved. I don't need absolute value. Now physics text usually doesn't care about these things, and they are sometimes lucky that the answer becomes right. So I mean that even if you didn't care, your answer was right. Yes? But you have to care. So that is the simple. Yes, it is simple, but it is not the same thing. The next of it is just trigonometry. We have to do something. But I want you to take lessons. If Kevin, you said, I want to put B and A, of course, now, which is easier than put the B and A there. Yes? So if you can simplify something in mathematics, this is a very nice take on lesson. You have to simplify and then replace. Okay, so let us continue together. Tan alpha is here. Minus tangent of alpha plus beta, and then divided by A times cosine alpha. So let me write minus, I multiply this by cosine alpha. So this becomes G cosine alpha divided by 2 V naught squared cosine squared alpha plus beta. Yes? By the way, you can stop here, because that is completely a reasonable formula. You express D in terms of your known parameters. Finished. But the point is that they want you to do it like that. That is probably the hard part. This is the only reason I think they have considered it as a level 1 problem in a university physics text. Yes? Okay. But I want to wait for you. Can you prove it for me? Start from this and use your trigonometric knowledge. Hopefully you have something in your memory, the formulas, and then you come back and prove it. Because otherwise might be that is a hard one. I don't have the formula sheet, but if you have a computer in front of you, you can Google it around if you need a formula. So I will pause recording and I want to give you time to find the formula for you. Okay, let me take a photo from here. So our goal is tomorrow we'll continue. So I want to take the photo from here and there. Yes. Okay. And then I will also continue tomorrow. I want you to think about this problem if you have time. I told you that the directions of the axes are arbitrary. We actually choose them and start solving them. Another natural setup is what? Can you tell me? There's another. I can choose this as my coordinate system here and start solving that problem there. That's also possible, but this is not reasonable. But there is another reasonable setup for solving this problem. What is that setup?
The y-axis on the other way.
So that is yes, that's also possible, but that is not a very big difference. It will take g to minus g to g. Yes.
Maybe using the straight line as the x-axis.
Yeah. So that is also. I hope that you agree. That is also a reasonable choice. And this will teach you a lot of physics, I would say. Yes? I want you to think, let me call it capital X and capital Y. You see, the problem is still the same. I am changing my perspective, how to look at the problem. Tomorrow I will continue proving this. If you can, that is very good. If you cannot, I can solve it for you. And then I want you to help me to do the physics problem in the new coordinate system. It will teach you a lot of physics, I think, and that's very instructive. And then, of course, tomorrow we'll finalize it, and then you will decide if you want to go in this direction or we want to change the topic, of course. But that is still very good to understand. Any questions? Okay, so yeah, think about mainly this problem. I don't know. In principle, after you are done, if you change the coordinate system and you understand what is going from mathematical and physical point of view, you should be able to get. But then there are some nice surprises there for you that I want to draw your attention to. Okay? So thank you very much.